Notes on exponential rules. Okay. There's some certain rules we need to know. All right? So, before we learn the rules, let's learn what a power is. Well, it is an exponent, right? You got to know that, right? Okay. So, x to the a. You ever see like some number 5 cubed, right? Something like that? That's a power, right? This whole thing is called a power. Okay? Okay? This, anybody know what that's called? Someone's got to know what that's called. The thing up top, let me go here. Anybody know what this is called? And if you say 3, I'm hitting you in the face. I'm just kidding. Exponent. It's an exponent. Right? It's an exponent. Come on, people. These are what kind of rules? Exponential. Exponent. Oh. Okay. Okay. Now a lot of you won't know what this is. That's okay. But does anyone know what this is? I thought that was orange. Does anyone know what this is? It's called the base. And the reason I call them these is so that later on when you learn logarithms next year, right? We need to know the base, the exponent, and the power. A logarithm is an exponent. Logarithms are simple. They're fun. All right? But we need to know exponential rules before we can get into logarithms, right? So this is what exponential rules are based upon. You have a base, you have an exponent, and the whole thing is your power. That's it. Okay? Now, when you take two powers with the same base, right? Now these vocabulary words might make a little sense. If someone just wrote to you, take two powers with the same base and multiply them, what do you do to the exponent? You're like, what? Okay? But it's not that hard. 2 powers, x to the 3. X to the 5. With the same base. Both x's. So in this case I'm going to say, actually let's just say a and b. Okay? Alright? It equals x to the a plus b. So now let's give it an example. Give an example. If I've got x to the 5 times x to the 8, then I get x to the 13. That's it. This is why I said, do you know how to add? Do you know how to subtract? Then you can do this. It's that simple. It really is. I'm just adding these. Bam, done. Good? Next rule. X to the a divided by x to the b. X to the a minus b. So when you multiply, you add. When you divide, you subtract. Simple. Think about it. X to the 5th divided by x to the 8th. Now, if I just do the math, okay, cool, that's x to the negative 3, right? And you're like, whoa, negative, what? I don't understand. Okay? But, if I wrote it like this, and then I cancel them out. 1, 2, 3, 4, 5. How many are left? And where are they? On the bottom. So this equals 1 over x times x times x. Which is 1 over x to the 3. Right? So wait a minute. You're telling me that x to the negative 3 is the same as 1 over x to the 3? And I'm telling you, yeah. That's our next rule. Okay? Our next rule is x to the a is equal to x, or 1 over x to the negative a. And vice versa. X to the negative a is equal to 1 over x to the a. That's all we're saying right there. Is that x to the 3, negative 3, is equal to 1 over x to the 3. That's all that says right there. It's very complicated, but that's all it's saying. If it's negative, put it down below and make it positive. That's it. If it's down below and it's negative, put it up above and make it positive. That's it. Okay? That's it. Alright. Now, one more rule, and then we're done. Power of a power. If I have x to the a raised to the b, then that equals x to the ab. Okay, so let's look at that. Let's think about that. Let's think about x squared raised to the 3rd power. Then that means that I have x squared times x squared times x squared, right? And then I would just add the 2's. Well, 3 2's is the same as 3 times 2, right? Either way, you're getting 6. Does that make sense? Now, if I just added these up, there would be 2x's here, and 2x's here, and 2x's here, right? Any way we look at it, it's x to the 6th. That make sense? So I can think of it as, I've got 2 x's, and then I've got 3 sets of them. That's 6 x's. All multiplying against each other. That's exponential rules. That's it. And now we'll do all the homework.